Hey, welcome to czverse. We spend a lot of time on this channel looking at AI agents, crypto, robotics, and quantum computing. But today, I want to step back and look at the physical foundation that all of it sits on. To understand the scale of this foundation, look at the capital flowing into it. Google committed up to $40 billion to Anthropic. Amazon committed $50 billion. Meta is spending $65 billion on infrastructure this year alone. And OpenAI is building $500 billion of infrastructure through its Stargate project. These commitments easily exceed the annual gross domestic product of many mid-sized nations. The industry is building a brand new class of global strategic asset. These allocations mirror the massive military buildups of the past, prioritizing physical infrastructure over standard software development budgets. In the 20th century, nations secured their interests with nuclear arsenals and naval fleets. Today, they do it with compute. The race for that infrastructure operates differently than normal corporate rivalry. It looks a lot more like a modern Cold War, fought through capital allocation, talent acquisition, and energy grids. The entities that secure this infrastructure will dictate the geopolitical reality of the next 20 years. To see how these modern alliances operate on the ground, look at Google's recent investment in Anthropic as a case study. This deal functions primarily through cloud compute credits. Google is essentially funding Anthropic's research by opening up the physical servers and processing power required to train frontier models on Google Cloud. Both sides extract strategic value. Anthropic gains the raw processing power required to survive the race to build the most capable frontier models. Google secures a critical stake in a safety-focused competitor to OpenAI, ensuring they have leverage regardless of which AI development approach ultimately succeeds. This structure reveals a hard constraint of the AI industry. Cash alone cannot buy a seat at the table. Raw, physical access to compute is the only currency that actually keeps a company on the frontier. When you zoom out from individual deals, you see a massive, interconnected network map of global alliances. The entire landscape divides into three distinct camps: proprietary U.S. ecosystems, an open-source alternative, and an isolated Chinese state network. The dominant incumbent position belongs to the Microsoft and OpenAI partnership. Microsoft provides the immense infrastructure capital, and in return, they get early access to integrate frontier models directly into Azure, Office, and GitHub. The primary challenger is the Google and Anthropic alliance. Google relies on its own custom TPU chips and vast global search distribution to maintain a separate pipeline that does not rely on competitors for hardware or reach. Then you have Meta operating as a massive wildcard. Mark Zuckerberg is using the Llama models to weaponize open-source AI. By making highly capable models freely available, Meta undercuts the proprietary advantage of the big alliances and prevents any single company from establishing an API monopoly. Running parallel to all of this is the Chinese ecosystem. Companies like Baidu, Alibaba, and Huawei are rapidly constructing a domestic infrastructure base with direct support from the Chinese government. The immense cost of competition means going it alone is mathematically impossible for most players.
Survival means building or joining a heavily fortified ecosystem. All of these digital alliances are completely dependent on physical reality. Training a frontier AI model requires thousands of processors running continuously for months in data centers exactly like this one. Right now, the entire global supply chain is bottlenecked by a single company. NVIDIA produces the vast majority of the specialized GPUs required for this training, leading to chronic shortages across the industry. The United States government understands exactly what this bottleneck means. The country that leads in AI capability gains direct advantages in intelligence gathering, military systems optimization, and economic productivity. Washington responded by enacting strict export controls. The policy is designed specifically to restrict China's access to advanced NVIDIA chips, attempting to strategically starve their parallel ecosystem of the compute it needs to train frontier models. Because of these stakes, major U.S. tech companies operate in a unique environment. They are fiercely competing businesses, but they are also de facto components of U.S. strategic infrastructure. The immense capital concentration at the infrastructure layer creates insurmountable barriers to entry. Startups and mid-sized companies are increasingly locked out of frontier model development because they simply cannot finance the compute required to play the game. If we project this forward to 2026 and 2027, the landscape tightens. The concentration of power among a few hyperscalers will attract aggressive regulatory action to establish guardrails, while open-source models will approach near-frontier capabilities, forcing massive shifts in the software economy. By 2028, the export controls and political friction will solidify into true geopolitical fragmentation. We will be looking at entirely separate, incompatible technological stacks. This map illustrates where this leads by 2030. The world will be cleanly fractured into distinct technological blocks. We will see multiple powerful AI ecosystems, each operating under different rules and directly aligned with the national interests of the US, Europe, and China. The billions of dollars flowing into data centers today serve as physical anchors for the next 2 decades. These investments represent the fixed infrastructure that will dictate the political and economic reality of the next 20 years. This infrastructure competition is the overarching context for every story we cover here. Every cryptocurrency movement, every robotics advancement, every new software product, they all sit inside the boundaries of this global compute race. I want to say a real thank you for spending time with this video today. These are heavy, deeply complex subjects, and I appreciate you taking the time to grapple with the actual facts. If you found value in this breakdown, please hit the like button and share it with someone who needs to see the bigger picture. Subscribe if you haven't already, so I can keep doing these deep dives. Before you go, drop a comment and tell me, what do you think will ultimately decide the winner over the next 10 years? Is it raw compute access, the actual capability of the models, or smart regulatory positioning? Let me know. This is czverse. I'll see you in the next one.